同学们，我们要上课了。好 ，OK， let's start to this week's material. Okay, today we have several topics need to complete. Okay, that here we are in here week number 14. But before we start, that will be our last topic of neural network. Okay, from next week, okay, we will introduce several different security related systems such as intrusion detection system, anomaly detection system, and some other systems that we can use help us to analyze security data. Okay, so today will be our last lessons about neural network, and we focus on the tool Orange. Okay, so let's get started with today's class. So we'll go to here and we open a new Orange. Okay, right here. Okay, so again, let's start with the simulated dataset. Okay, so we use the dataset which is iris right here. Okay, 150 instances and 4 features, and all of them are numeric features, and one categorical target is right here. Okay, so let's just take a very simple model evaluation right here. So we have a test score right here. Want to test several different models, so we simply just pick some easy and basic, very classic algorithm right here. Okay, so the next one is neural network. Okay, sometimes we don't want to write programs by using Python. So if these are very easy problems and you want to model a problem by using Orange, which is okay. So we have a neural network right here. So basically, okay, so let's take a look at this table right here. Okay, so again, iris. So this is the categorical data. Okay, 3 different classes and 4 features. Okay, all numeric features. Okay, so we connected the data to here, the test and score, and we have 3 different models: linear regression, logistic regression, SVM, and neural network. Okay, before we continue, okay, let's take a look at each the parameter of each model. For example, logistic regression right here. Okay, before you apply your logistic regression model, okay, you can choose different regularization types, and here we have 2 different regulation, which is L1 and L2, which is lasso and the range regulation. We have explained what is the difference between lasso and the range. Okay, basically we usually we use L2 regulation after we before when we apply logistic regression. So the loss function we used right here is not merely RSM square root, mean square root. Okay, we have talked about it before. So let's take a look. Let's take a look right here. Okay, when we talk about regression, okay, and usually again, regression, right? Of course, there are several different models. For example, if it is a linear regression, it is something like that, right? If it is logistic regression, it is something like that. So we have several different weights need to be applied. And when we talk about regression, its loss function, usually it is like this, right? We've talked about this before. Okay, we have okay, y hat depends on what kind of model you are using. Okay, so whenever this square, okay, that is regression would like to use. Okay, so basically when you want to add some different consideration by using regularization. Okay, so if you want to use L1 regulation, okay, and then your loss function will become, again, it is the same in the very first place. Okay, however, okay, you have to add another items right here, which is try to minimize the weight, your weight. So the weight is right here, right? And usually we write it as W. So you can minimize. Okay, so we have minimize right here. Minimize. Right? We have minimize right here. So basically, when you apply loss regularization, okay. Sorry. When we say L2, it's right here. Okay. L1, that means you simply just use the same thing right here. But L2 and L1 simply just means you use square or you do not use square right here. But basically they minimize the weight you use. So you don't have very large weight. Okay, if some weight is if some variables right here, they are meaningless to the output, which is y, which means the relationship between the x and y, they are not very they're not very important. So the weight should be very, very small. Okay, so by applying regularization, no matter it is L1 or L2, okay, as we mentioned it before, it can help us to select important features, which is x1 to xn. Okay, how? By apply a very small weight. Okay, if the feature is less important, then the weight should be less, close to 0. Okay, so regulation is right here. L1 regulation and L2 regulation, that can help us to minimize the weight. So if the feature is corresponding weight, the corresponding feature is not important, the corresponding weight will be very, very small by the regularization. Okay, so I think we have talked about before. So let's go back to orange. So it's right here. Okay, that is so basically when you do machine learning algorithms, okay, especially by using tools like orange, okay, make sure you select such kind of regulation. Okay, so SVM, okay, we have talked about it before. Okay, they have different kernels right here. Okay, so let's take a look at the neural networks. Okay, the neural network model provided by Orange is very simple. Okay, it's very, very simple, and I believe it can only solve some very basic problems. So if you have a very complex problem need to deal with, basically I recommend you write your own code by using Python, TensorFlow, or Keras. You don't want to use Orange because the neural network is too simple. Okay, so basically you can see that there are several different parameters you can set in this model. Okay, the number of neurons in hidden layers. So 100 right here means I would like to create a simple neural network which has only one layer, because it has only one numbers, and in this layer it has 100 neurons. Okay, so basically we can see that we can for example, okay, I change it to 100. Okay, so basically we can apply different parameters on models. So I use another neural network right here, but in this neural network, okay, I write in this way. That means I would like to have 2 hidden layers, and for each hidden layers, it has 100 neurons. So we can simply write it like this, okay? And of course, you can choose what kind of activation function you want to use. So basically, it says we have several different activation functions like ReLU, hyperbolic tangent, identity. Identity means we don't apply any activation function. Okay, logistic, which means sigmoid. Okay, so we use ReLU right here. Okay, so the solver means optimizers. We have talked about before. You can choose Atom or SGD or some more complex optimizer. However, they have Orange has only 3 different optimizers. Okay, and we have the regularization, which is the same as we talked about, which is if you want to apply regularization on your loss function. Okay, so here's the maximum number of iteration is how many partial differentiation you would like to apply on when you do such kind of training. Okay, so basically the neural network model provided by Orange simply just like that. How many number of layers, hidden layers, and for each layer, how many neurons you would like to deploy, what kind of activation function you like to use, what kind of a solver, which is optimizer, you like to use, and regulation, and how many times of iteration, which means partial differentiation you like to apply. Okay, so after that, we still can attach the confusion matrix right here. Okay, so here's the result. And maybe you would like to add one RC curve right here. Okay, so we can see that. It should be like this. Okay, so let's take a look at this confusion matrix. Okay, and of course it is a classification problem, so we still have several results right here. Okay, so sampling right here. We usually use cross validation, which means tenfold cross validation, which means again, okay, we partition the original training data into 10 different data set. Again, we use 9 data set for training and 1 part for testing, and we do such kind of partition 10 times. Okay, we iteratively replace the testing data. Okay, so here's the result, and we can see that for such kind of simple data, iris data, okay, so the classification rate right here, okay, they're quite high. Okay, because this is very, very simple data. Again, and we can see that if you apply different parameters on neural network, for example, this model has 2 layers, each layer has 100 neurons, and this neural network is much simpler. It has only 1 layer. Okay, the classification rate is different. Okay, of course, it says that it is not necessary that you have a very, very complex neural network and you guarantee has a better classification result. The statement is wrong. It's not correct. Okay, we will talk about what is the reason why a complex neural network may not indicate better result. Okay, so basically you can for example, we can simply just add more neural network right here, for example right here. Okay, and let's try some other interesting things. Okay, if I have 10 neurons, but maybe 13 neurons, 20 neurons, 10 neurons. Okay, and I apply. That is good enough, I think. Okay, just a test. Okay, so I'd like to see what is the difference between layers and neurons. Okay, so results like that. We can simply just ignore those things. I think that is not important in our remote. Okay, so we have 3 different neural networks, and each of them has different settings. Okay, so we can see that because it is a very simple data set, so it does not reflect the relationship when you using different layers, different number of layers, and different number of neurons. Okay, so maybe we can try some other interesting things, such as housing, maybe. Okay, and for housing, then we can see that all of them are still numeric data, right? But we don't have the target, right? So so let's try. The target is right here. Okay, target is right here. That's good. So let's take a look. But since the target right here, okay, let's make sure. Since the target is numeric data, okay, numeric data. So we don't have classification result. Okay, we don't have such kind of things. We can simply just take a look at this one. Okay, and also we can choose MSE value or square MSE value. Okay, to if you have smaller MSE value, which means your prediction data is close to your true target. So you have a lower MSE. So we can see that we have different settings of neural network right here. Okay, 2 layers, 3 layers, and different neurons right here. It is not necessary. It means if you have a complex neural network, for example, for me, if your network is more than 3 hidden layers, and I will call it deep neural network. Okay, because it has several different layers and it is deep. Okay, but it does not guarantee that your MSE is lower than neural network, which has only 2 layers. Okay, so basically you can try yourself. Okay, you can try different. For example, maybe we use some other activation function right here. Okay, so I said 100 right here, and I said it's hyperbolic tangent. Okay, so I connected this one to here and see the result. Okay, so again we sorted by MSE, so it means okay, you can see the difference. When you use ReLU or you use hyperbolic tangent, okay, the result is different. Okay, the result is different. So sometimes you need to try how many different layers you would like to use, and for each layer, how many neurons in each layer, and what is the activation function you would like to use, because different activation function has different result. We will show you how different layers and different neurons and how different activation functions can help us to design our model, okay, which will be the next hour. Okay, so sometimes try, okay, try it yourself to see the difference between different design of neural network. Okay, that is. So I think that's good enough. Okay, so that is the neural network you may want to use, but that is the only parameters you can change right here. Not much. For example, if you want to apply convolution neural network, you want to apply max pooling. No, Orange does not provide such kind of layers. Okay, they are simply just a very simple layers. Okay, it has activation function. It has the parameters to help you to design your neural network. But that's it. That's it. If you want to apply different layers, different types of layers, you have to use Keras or Python by yourself. Okay, so that is the neural network. If you want to use Orange to use your to design, usually we use such a kind of tool to do quick test. Okay, to see if some very simple neural network can deal with the complex problem or not. Okay, so that is, and I would like to talk about one more things about different layers. Okay, as I mentioned before, we have some more complex layers such as convolutions, such as pooling, and here Okay, we have another kind of layer which is called dropout. Okay, dropout. Okay, so let's go back to my iPad. Okay, so okay, it's right here. I'd like to say something about dropout. Okay. Okay. Usually we design our neural network like this. We write it many times. Okay. Let's see if we have only one hidden layer. So hidden layer 1, hidden layer 2, something like that. Okay, something like that. And we have output right here. Okay, so it's a very simple neural network, right? So we said that there's a weight right here, right? For example, 1 1, 2 1, 3 1, and 1. Okay, there's another weights right here. That is would be 1 2, that would be 2 2, something like that. Okay, so when we passing the information from the left hand side, which is the input, to the right hand side, which is the output. Okay, of course we can apply regulation. Okay, as we mentioned before, so that those weights can help us to pick, okay, to select different features. Okay, important features will have larger weights. Less important features will have smaller weights or 0 weights. Okay, so the information can pass like that. However, sometimes, okay, we would like to apply dropout, which means, okay, dropout, which means when we do training, or testing, okay, sometimes, okay, usually dropout, the mechanism of dropout is applied to the neural network, okay, in some way of random. So sometimes you can call it as a random dropout. Okay, it has certain probability. Okay, certain probability. So you can set such kind of probability. Okay, when you do such kind of information passing from the left hand side to the right hand side. Okay, for example, right here, it has a certain probability. Okay, sorry. It has a certain probability that when you do training or testing, let's weight, okay, for example, W31 will have certain probability that the weight will be set to 0 when they pass the information from X3 to H1 between this random node, which means the information will randomly drop it. So let's call drop out, okay? The information will randomly drop out when we do training. So for certain when we do training, okay, W3, the information of X3 will not pass to H1. Okay, and we will do such kind of random dropout. Usually the probability will set to 0.5, which means half of time when we do training. Okay, when we pass the information from X3 to H1. Okay, half of the time, half of the training time, information will not pass from X3 to H1. Okay, so that means the information is lost right here. Okay, so when we do such kind of training, okay, the neuron, of course, when we set up dropout, okay, the dropout can be set something like right here, or between any layers, okay, between any layers. So the information lost, okay. So why do we want to do such kind of design. Okay, so let's go back to here. Okay, let's first take a look at how do we use that. And so that is that. Okay, we have a keyword. Okay, there's called dropout. Okay, so here we have a rate, a parameter called rate. Okay, usually we set it to 0.5 or some data. Okay, so you can see that the dropout layer randomly select input unit, okay, from the left hand side, okay, between any layers, okay, to 0 with frequency of rate, which is usually 0.5, okay, at each step, which means when we do training, okay, which helps prevent overfitting, okay, so that is very important. Dropout helps us to prevent overfitting. Okay, so here's the result. Here's the definition right here. So how do we design a layer? So right here, okay, we have the dropout layer right here, and the probability right here is 0.5 0.2, which means 20% of the data will be lost when we do such kind of things. Okay, so so that's it. So that's it. Okay, the reason why we use kind of such kind of dropout, that means we want each neurons. So let's go back to here. Okay, just right here. So when we pass the information from the left hand side to the right hand side, okay, so if sometimes the information does not, for we take a look at each one, okay, if sometimes the information does not pass from X3, okay, however, some for H1, okay, some information still pass from, for example, from X1, X2, or XM. So when H1 would like to provide a point of view, right? We talked about before, H1 is a hidden neuron, okay? It provides certain kind of point of view of the input data, which is from X1 to XM. And H2 has different point of view of the input data, and H3 has another point of view, viewpoint to the data, okay? So if sometimes H1 does not receive information from X3, that means the information content in the X3, okay, should sometimes, okay, provided by H2, because sometimes H1 does not receive information from X3. However, because the dropout is randomly, right, so information of X3 can still pass to H2 or H3. So H2 and H3 can still provide some point of view of the data of X3. So that Y, okay, can make a decision how to output the Y. So that means you don't rely on only one hidden node, for example H1, to represent, okay, the point of view of X3. So that guarantee the information of X3 can be passed to H2 and X3. And even if H1 does not provide such kind of information of H3, H2 and H3 can strongly pass the information from X3 to Y. So that means even if H1 does not work properly, okay, H2 and H3 can still independently pass the information from the left hand side to the right hand side. Okay, you can imagine that if we apply regulation on this weight, okay, what if, okay, I say what if, okay, I use another color. Okay, let's take a look at this one. Okay, right, we have weights right here. Okay, so third one. So here is W32. Okay, so we have several different. We have several candidates that can express. So here. Weight W31, W32, W33. They all pass the information from X3 to hidden node 1, hidden node 2, and hidden node 3. Right? What if we apply regulation and they set this weight W32, W33 to 0? Sometimes it happens. Okay? If we apply regulation, L2 regulation. Okay? So that means the information only passed from X3 to hidden node 1 because W32, W33 are all zeros. So if sometimes, so we in such kind of situation, we highly rely on H1 to represent the data of X3, which is not good. So if we apply a regulation, okay, so sometimes we wish, okay, those weight 3 to 1, weight 3 3 should not close to 0. So it's sometimes kind of trade-off, but neural network will adjust the weight by itself. Okay, so it is a trade-off between dropout and regularization. Okay, so that is a dropout. So basically the dropout. So sometimes, okay. As we said, okay, it has another pros, which is overfitting, to prevent overfitting. Okay, that is a very important features that dropout layer can provide. And what is prevent overfitting? That means even if the quality of the input, okay, this is right here, it's not good enough. Okay, it's not good enough. Or as we can see that this weight can still provide different kind of point of view and pass the information to the left hand side to the right hand side. Right? So the neural network, each neuron, hidden neurons, can independently, okay, make some point of view and provide it to Y to make a decision. Right? So if we do not apply such kind of dropout layer, okay, you will see that some neurons, okay, for example, some neurons right here, they will be activated by certain input data, and the rest of, as we mentioned, the rest of the neurons will not active by the input, which is X3 in this example. So that in this case, if we input different data right here, and X3, the data quality is not that good. So the input of X3, for example, does not provide enough information, and H2 and H3 will not activate. So that will be not good. That will be very useless. Okay, so we apply dropout. So the point of view, the point of view can be can be spread in different neuron, H1, H2, and X3. So that can help us to prevent the model will fix and will only fit for certain kind of input data. Okay, as we mentioned, when we do testing, okay, there are different kind of data. Okay, they are not necessary has the same distribution of your training data. So if the data is a little bit different, okay, so our hidden neurons H1, H2, and H3, they are strong enough to provide different point of view of the input data. Okay, the result will be more robust when you apply dropout layer in your neural network. Okay, So the basic idea is that we usually apply some dropout layers in your neural network. Okay, so let's go back to here. Okay, so here is a explanation of overfit and underfit. So so I recommend you take a look at these this kind of articles. Okay, where I put the link in our website. So when we talk about overfit and underfit, usually we use figure like this. Okay, so for example, if we have x right here, there's a y, and we have several data right here. Okay, so usually if we do a model which is linear regression, okay, that might be good model, right? So if we say overfit, what does overfit mean? Overfit means your model will fit the data quite well, right? And when we say underfit, that means your model, we can add some more point right here. Okay, so we can see the difference between. So underfit maybe that means okay. Overfit, sorry, overfit. So underfit maybe means the model you create is not quite fit the model. Okay, so maybe okay, maybe that is something. So you don't want those weights remember the input data when they do the training. What means remember? That means for each neuron, they will be activated for specific data. For example, right here, if there is a neuron, there is a data point right here. However, it is maybe that is an outlier, or it is an anomaly data, which should not be included in your model. But however, you have some specific neurons, okay, they have specific weight which can activate this data point when this data point are fed into your neural network as input. Okay, some neurons and their corresponding weight will activate it by this. So the corresponding the Y, they will output such kind of Y. However, maybe this data is anomaly data, is outlier data. You should not ask some neurons to remember. To remember means set specific weight. Okay, to activate this kind of input. Okay, so maybe you don't need to do so. So when you apply dropout layer randomly in your neuron, okay, the neuron may not activate for such kind of specific outlier data or anomaly data, because you randomly drop out its weight. Okay, so that is the reason why we use dropout layer to deal with overfit data, overfit model. Okay, so that is, so I think that is good enough. So let's go back to here. Okay, so the next hour we will talk about the text-based analysis with Orange. So if you so we can close this one. Okay, so before we take a break, okay, so make sure you have your Orange ready. Okay, so and also here is an option right here, and here we have add-on options right here. Okay, there are several different add-ons that can be downloaded from the network. Okay, so make sure you have your text, which is right here. Okay, which is right here. That means I would like to use some text mining widget because we like to analyze text-based data. We mentioned it before. When we analyze sequence data or time series data, we have several different techniques to help us to analyze sequence data or time series data. For example, we can use one-hot encoding. We can use one-hot 2-gram encoding. We can use several different ways. But however, if it is a text, for example, it is a book, it is an article, so we have several different ways to transform the original text-based data to numbers. And after we have numbers, then we can apply different models. Because we, for example, SVM, linear regression, neural network, all those models we taught in this class, okay, most of them deals with numeric data. We don't directly input Apple, this word, to neural network, because neural network does not know what Apple is. You have to convert your original data, which is text, which is a sentence, which is a paragraph, which is an article and document, to so make sure you click your Orange has such kind of add-on, okay, and you click OK, then Orange will download the Orange text libraries, okay, libraries from network, so that you can, when you so if you are correctly installed the things, there should be one more tabs right here, which is text mining, and we have a very useful tools, which is right here, where we introduce next hour. Okay, so make sure you have those widgets ready. Okay, so let's take a break for 10 minutes and come back at 10 after 10. Okay, that's it.